everyone, my name is Mrs. Mountjoy and I teach kind of across the hall in room E314. I teach geometry and pre-AP Algebra I, and I'm going to be teaching your lesson today for student notes 12-2, Simplifying Radical Expressions. So we're going to go ahead and look at this first problem together. Simplifying radical expressions is just like combining like terms. So combining like terms such as 2x plus 3x. Since they both have x's, you can add them together, and that equals 5x. But if you try to do 2x plus 4y, you could not combine these two because they both have different variables. One has an x and one has a y. So this is already simplified. You can't do anything more with it. Same thing with radicals. In order to add or subtract radicals, you have to have the same number underneath the radical sign. So in example number 1, 4 square root of 7 plus 5 square root of 7, they both have a 7 underneath the radical sign. And since 7 is prime, you can't simplify it either. So we would just go ahead and add these two terms together. So you would add 4 plus 5, because those are the numbers on the outside of your radicals, 4 and 5, which is 9. And you would leave the square root of 7 alone. Just like when you're combining like terms, 2x plus 3x, you add the 2 and the 3 together, but you leave the x alone, 5x. So this would be 9 square root of 7. Okay, what I'd like for you to do now is, whoever is the substitute in the classroom, please pause this video so that the students can work on number 2 for a few minutes by themselves on their own, and then you can restart the video. Okay, now that you've had a few minutes to work on number 2 on your own, you should have seen that the square root 11 and the square root of 11 are the same in both of these terms, so you can just simply subtract them. 8 minus 2 are the numbers on the outside. 8 minus 2 is 6, and then square root 11 you would leave alone. So 8 square root of 11 minus 2 square root of 11 is 6 square root of 11. Okay, we're going to go ahead and move on to example number 3. Well, number 3 isn't as simple as number 1 and 2. If you look at the square roots, we have square root of 6, square root of 13, and square root of 6. So not all of them are the same. So what you should notice is that the square root of 6 on 3 square root of 6 matches the square root of 6 on the 5 square root of 6. So these two terms are considered like terms because they have the same number underneath the radical sign. Just like up here when the 2x and the 3x were the same like terms because they both have variables of x. So what we're going to do is we're only going to combine the ones that are like. So the 3 square root of 6 plus the 5 square root of 6 are the two that can be combined because these are like terms. The square root of 13 cannot be combined here. So 3 square root of 6 plus 5 square root of 6 is 8 square root of 6. And since the minus 2 square root of 13 cannot be combined, we just would attach this at the end. So you're only combining the things that have the same number underneath the radical. Okay, go ahead and pause this video again and try number 4 on your own. Okay, now that you've had a few minutes to try number 4 on your own, let's go ahead and talk about it. You should see the like terms here are the 7 square root of 3 and the minus square root of 3. Okay, and the other two that are in common are the 2 square root of 2 and the minus 3 square root of 2 because they both have a square root of 2. So let's just focus on the 7 square root of 3 minus the square root of 3. Well, you might be wondering, well, there is no number in front of here, in front of the radical sign. It's an understood 1. So it would be 7 square root of 3 minus 1 square root of 3 is 6 square root of 3. And then 2 square root of 2 minus 3 square root of 2, 2 minus 3 is negative 1 square root of 2. So our answer is 6 square root of 3 minus 1 square root of 2. You could also write it as negative 1 square root of 2 plus 6 square root of 3. Either order would work in this situation. Okay, let's go ahead and look at number 5. Okay, number 5 has 5 square root of 192 minus 7 square root of 3. Well, right now we don't have any matching radicals, numbers under the radical. We have a 192 and a 3. So we can't do anything until we simplify the 5 square root of 92. Okay, well, 192 is a large number. So let's go to our calculator and see how can we simplify 192. Okay, I believe that Miss Irvin showed you this trick where you take 192 and you put in y equals, and then you divide it by x on your calculator. Okay, after you've done this, you can then look at your table, second graph, to look at your table. And from your table, you want to find the biggest perfect square. 1 and 192, 296, 364. Okay, I know that 64 is a perfect square, so we're going to use 64 and 3 as our factors for 192. So let's simplify. 5 square root, instead of 192, we're going to write 64 times 3, because those are the two factors I just found. The perfect square is a 64, and the square root of 64 is 8. So now that you've taken the square root of 64 as 8, you bring it outside the radical with the 5. And remember, once you bring it outside with the 5, you have to multiply them together. So 5 times 8 is 40 square root of 3. Okay, now that we've simplified 5 square root of 192 to 40 square root of 3, now you can subtract 7 square root of 3 from the 40 square root of 3 because they both have square root of 3. Well, 40 square root of 3 minus 7 square root of 3, you just subtract the 40 minus the 7, and you get 33 square root of 3. Okay, what I'd like for you to do now is pause this video, try number 6 on your own for a few minutes, and then we'll talk about it in just a second. Okay, now that you've had a few minutes to look at number 6, let's talk about it. You should have noticed that the square root of 2, the square root of 27, and the square root of 98, none of those are in common, so you can't combine them. So you're going to have to simplify them first. Well, 25 square root of 2 is already simplified, so we can't do anything with this. However, we can simplify 2 square root of 27 and negative 3 square root of 98. Let's start with 2 square root of 27. So we need to find the biggest perfect square that goes into 27. So let's go to our calculators, go back to y equals, and type in 27 divided by x. Now go to your table, second graph, and we need to find the biggest perfect square. 2 and 13.5, that doesn't work. 3 and 9, that does work because 9 is a perfect square. Okay, and that's the biggest one we're going to have on our list. So 3 times 9, okay? So when we simplify this, we're going to put the perfect square first, 9 times 3. The square root of 9 becomes 3, so we bring that outside with the 2. So we have 2 times 3 square root of 3. The square root of 3 comes down. 2 times 3 is 6 square root of 3. Okay, so now we've simplified 2 square root of 27. So right now we have 25 square root of 2 plus 6 square root of 3 minus, okay, now we have to simplify 3 square root of 98. Okay, well, we got to simplify the 98. Let's go back to y equals 98 divided by x in our calculators. 1 and 98, 2 and 49. There, right there, 49 is a perfect square. 7 times 7 is 49. So we're going to use 2 and 49 as our factors. So we have 3 square root of, and the factors of 98, our perfect square that we found was 49 times 2. Okay, well, the square root of 49 is 7, and that comes outside of the radical sign with the 3. So it comes out here. And then the square root of 2 stays underneath the radical sign. 3 times 7 is 21, square root of 2. Okay, so now we've simplified 3 square root of 98 as 21 square root of 2. So now we can combine those that are like terms. Okay, well, the ones that are like terms here are 25 square root of 2 minus 21 square root of 2. Well, 25 square root of 2 minus 21 square root of 2, 25 minus 21 is 4 square root of 2. And then we can't do anything with the plus 6 square root of 3 because it's not a like term. So our answer would just be 4 square root of 2 plus 6 square root of 3. Okay, let's move on to number 7. Okay, you should notice something a little bit different about number 7. We're no longer adding or subtracting, we are multiplying. Okay, multiplication has totally different rules than adding and subtracting. Just like when you multiplied x times x, you get x squared. It's different than adding x plus x, and you get 2x. Completely different rules when you are multiplying. Okay, so when you are multiplying with radicals, it's actually a little bit easier because you don't have to worry about like terms. All you do is multiply the numbers underneath the radical sign. So in this case, we would multiply 2 times 72. Let's go to our calculators. 2 times 72 is 144. Well, that's nice because 144 is a perfect square. So the square root of 2 times the square root of 72 is the square root of 144. And the square root of 144 is a perfect square, which is just 12. So the answer to number 7 is 12. So I want you to go ahead and pause this video and try number 8 on your own for just a few minutes. Okay, now that you've had a few minutes to look at number 8, let's try it together. Remember, when you're multiplying, all you're going to do is multiply the numbers underneath the radical sign. So square root of 4 times the square root of 75 is just the square root of 4 times 75, which is 300. Well, 300 is not a perfect square, but we definitely know how to simplify the square root of 300. If you need help in knowing what perfect square goes into 300, remember, put 300 divided by x into your calculator. And look at the table. 1 and 300, 2 and 150, but neither one of those is a perfect square. 3 and 100. Great, 100 is a perfect square, so we want to use those two factors. So 100 is our perfect square times 3. Well, the square root of 100 is 10. That comes outside the radical, and we bring down the square root of 3. So the answer to number 8 is 10 square root of 3. Okay, this brings us to our last two problems, number 9 and 10, which are very simple problems. You're taking the square root of a fraction. But what's nice about these fractions is that the numerator and the denominator in this case are both perfect squares. So the square root of 9/16 is the same thing as taking the square root of 9 over the square root of 16. So we're just making the radical on both the top and the bottom. Well, the square root of 9 is just 3, and the square root of 16 is 4. So the square root of 9/16 is 3/4. Okay, I want you to pause this video and go ahead and try number 10. Okay, let's look at number 10 and finish this off. The square root of 169 over 81 is the same thing as the square root of 169 divided by the square root of 81. Well, the square root of 169 is a perfect square, so the square root of 169 is 13, and the square root of 81 is just 9. So the square root of 169 over 81 is 13 over 9. Okay, we have finished our student notes for today. If you turn these notes on the back, you will see your practice, your assignment for today, number 1 through 11. You need to complete this in class with the remaining time in class. If you have any questions today, please come see me in room E314. Hope you guys have a great rest of your day.